question 9c, we're asked to find this integral, and we need to put it into the form ln a plus root b, where a and b are integers. So if we use the result we got from question 9b, that was secant 2x plus tan 2x, which is our integrand here, and we just use this expression here, it's going to make solving this integral much easier. So if we rewrite our integral then, so going from 0 to pi over 6, and it's cos x plus sin x all over cos x minus sin x, and take that integral with respect to x. So there's a couple ways you could do it. You could do it just by inspection, I guess, but I'm going to do it using a substitution. So we can notice that our denominator here, cos x minus sin x, if we take the derivative of that with respect to x, it's just a constant multiple of our numerator, cos x plus sin x. So if we let u equal cos x minus sin x, then du by dx is equal to negative sin x minus cos x, and therefore we're going to get our du is equal to negative sin x plus cos x dx, and so negative du is equal to sin x plus cos x dx. So now we've got that, we've got our expression for du, so now we can change our limits of integration. So we know when x equals 0, well, u is going to equal to cos of 0 minus sine of 0, which is just equal to, well, cos of 0 is 1 and sine of 0 is 0. And then the next part, when x is equal to pi over 6, well then u is equal to cos pi over 6 minus sine pi over 6, which is equal to, well, cos of pi over 6 is root 3 over 2, and sine of pi over 6 is a half, so minus a half, so that's equal to root 3 minus 1 all over 2. Okay, so now we've got our new limits of integration. If we integrate with respect to u, we've got our expression for du up there. So wherever we see sin x plus cos x dx, we just replace that by negative du, and then our part in the denominator, cos x minus sin x, well, that is u, so we're just going to write u. So therefore our integral is going to become, so I have to scroll down a bit of space, so therefore our integral is now going from 1 up to root 3 minus 1 all over 2, and we're going to have negative du, so negative du, and then we've got 1 over u for the 1 over cos x minus sin x. Okay, so integrating that, it's a fairly straightforward one to integrate. We're going to get negative natural log of u, and with our limits of integration, so root 3 minus 1 over 2, and working that out, so we'll plug in the root 3 minus 1 over 2 first, so we're going to get negative natural log root 3 minus 1 over 2 minus natural log of 1, and that is equal to, well, natural log of 1 is just 0, so we're going to get negative natural log root 3 minus 1 over 2, and then just using our rules, our laws of logarithms, so we've got this negative over here, so negative natural log, just here. Okay, and we can just make that to the power of -1, so that is equal to natural log √3 minus 1 over 2 to the power of -1. So that was just taking that negative there and using the laws of logarithms. So that is now equal to, or natural log of 2 over √3 minus 1. Okay, so we're almost there, but we've got this √3 minus 1 in the denominator, yeah, and a 2 in the numerator. And we actually want our answer in the form of natural log of a plus b. So all we have to do now is we can rationalize the denominator here for that 2 over √3 minus 1. So if we do that, we get this. So now 2 over √3 minus 1, that is equal to 2 over √3 minus 1, just times top and bottom by √3 plus 1. And expanding and simplifying that out, we get 2 √3 plus 2 over 3 minus 1, so that's equal to 2 √3 plus 2 over 2, and cancelling the 2's, we're going to get that's equal to √3 plus 1. So therefore, natural log of 2 over √3 minus 1 is equal to natural log of √3 plus 1, and that is equal to ln1 plus √3. So we're just rewriting it in the same form that they asked us in the question. Okay, and that is question 9c.